Hey guys, we're gonna pick up at section 5.7. 5.7, the title is Financial Models, which is more application or equation. Model is just really financial application problems, and write an equation based on interest and finance, the fun stuff. Very exciting. Okay, so the first definition is called simple interest formula, which is the reason it's called simple interest is because it's very simple to use and calculate. If a principal of P dollars, which is P is the amount the initial amount you're going to lend somebody or you're going to borrow somebody. It's borrowed for a period of T years at per annum, which is each year. Interest rate R expressed as a decimal. The interest amount I charge is I equals P times R times T. Interest charge according to the formula number 1, which is formula number 1, is called the simple interest. So it's so easy to use. For example, I'm going to go out and borrow, okay, $1,000 to pay off my computer at an interest rate of 9.5%, and I would like to borrow that for 2 years. Okay, how much interest do I have to pay back at the end of the year? Or I'm sorry, at the end of 2 years. So to calculate that, I'm going to ask you to go find your calculator. Okay, so do me a favor, go ahead and hit pause and find your calculator. So now that you have your calculator, the interest, I is the interest amount. Okay, so I equals P is the principal or the amount of money that we borrow or let someone borrow at the beginning of time. So I borrow $1,000. R is the rate in decimal. So right now it's in percentage. To make it to decimal, move it 2 spots. So 0.95 times 2. Okay. So I would like for you to use a calculator. How much money in interest wise am I going to have to pay back in addition to my $1,000? Alright, so hopefully you have already calculated it and got the same amount of money as I did. So after 2 years, I would have to pay $195 in interest. Sorry, that's $195. So I would have to pay back $1,190 total. Okay, so that's how we calculate I. All right. Next one is called compound interest formula. Compound interest formula is the amount A, which is at the end of the time that you borrow. The amount A after T years due to a principal P, which is the initial amount that you borrow or invested, at an annual interest rate R compounded n times per year is A equals P times 1 plus R over n to the power of nt. Okay, this is probably more applicable to the financial institution, because when you go borrow money, they normally don't just say once a year is how much you're gonna have to pay me back. They usually calculate it semi-annually or quarterly or monthly or daily. Okay, so this is more when it's compounded more than one time a year. So let's define some vocabulary here. Annual, okay, annual is obviously one time a year, so once per year. Semi-annually is twice per year. Okay, so if it's once per year, then you don't have to use this formula, but it will get you the same answer. Once a year, that means n is 1. Okay, and if it's semi-annually, that means n is 2. If it's quarterly, this is 4 times per year. Okay, and what does that really mean? Okay, what it means is this, that they take the money that you borrow. So let's just say quarterly. They take the money that you borrow, they calculate the interest quarterly. That means for the first quarter, if you have 12 months in a year and you divide by 4, that means every 3 months they calculate the interest. and they add that interest back into the total amount that you borrow. So that in essence, you're kind of paying more because now you're paying interest on the principal you borrow, and the interest you're paying interest on the interest that you have accumulated during the first 3 months. Okay, so that's why a lot of institutions, they like to calculate interest not once a year, as much as they can, so that way they can get more money from you. Okay, so let's go on to the next one. All right. Monthly and daily and continuous compounding, which is the very next one. Monthly, it's, we all know, is 12 times per year. And daily, we're always going to use 365 times per year. Okay. Continuous compounding is going to keep on compounding forever. So we're going to use E, which is sort of a review of Algebra 2. So this is really not new to many of us, okay? The amount A after T years due to a principal P, the same. So A is the amount you owe after. P is the initial amount you borrow, invested, of an annual interest rate R, compounded continuously. That means it's more than daily, it's more than hourly, it's more than I can't, you know, secondly. So it's keep on going forever. So A equals P times E to the RT. And I know a lot of you said this is kind of spells like PERT. So if it's continuously, this is the magic word right here. If it's compounded continuously, then you would use PERT. Okay. So here we go. We're going to do our very first easy example. Okay. Example 1. Find the amount A that results from investing a principal P for $2,000 at an annual rate of R, which is given to us at 8%, compounded continuously for a time T of 1 year. So all the stuff that we know. Okay. We know that we're going to invest $2,000. Okay, always write down the things that you already know. We're going to invest $2,000. We have an interest rate at 8%, which we need to convert that out to decimal, which is 0.08. And compound it continuously. So compounded. Magic word is continuously for a time of 1 year. Okay. So these are all the information that we do know. What are we looking for? Find the amount A. Okay, so find A. This is what we're looking for. So anytime you see the word compounded continuously, we're going to go use PERT. So A equals P times E to the power of RT. We're looking for A, so A keeps A as A. P, we know that's $2,000. E is an awesome value to the power of rate, which is in decimal 0.08, and time is 1. All right. So do me a favor and use your calculator and input that in for me. So 0.08 times 1, it's going to be 0.08. So remember, follow along. It's easy to see someone punching the calculator, but when you do it on the test, you might get confused. So if I were you, I would just follow along and punch in numbers as I go. So I'm going to do E first. So second, remember there are two locations to find E. One is below log, and the other one is it's on the division sign. Okay, so both second. Okay, so I'm going to hit second natural log. So second natural log. So now I'm at E to the power 0.08. I'm going to hit enter. I don't want you to round ever until the very, very last step. Okay, so throughout the problem, I do want you to write out all of your decimals. So now I'm going to take that and multiply it to 2,000. And at the very last step, because we are dealing with money, round to 2 decimal places. So A equals, put the unit back, 2166.2 decimal places will put me at 57. Okay, so in the end, you're going to earn $166.57. So $166.57. And then since you invested $2,000, you're taking all of that back home. Okay. Okay, let's move on to example 2. Example 2. Suppose you want to open a money market account. You visit 3 banks to determine their money market rates. Bank A offers you 4%. So let's divide up our papers into 3 banks, okay? Bank A. Bank A. So anytime you have multiple things going on, organize yourself. Bank A offers you a 4%. 4%. Annual interest rate compounded daily. So I'm going to spell compounded daily. Okay. Bank B offers you 4.1%. Bank B, R equals 4.1%. Compound monthly. So compounded monthly. Okay, and Bank C offers you 3.95%. Compounded continuously. Magic word, right? Okay. The question is, determine which bank is offering the best deal. Okay, and this is sort of the things you're going to need to do when you are on your own. When you have money and you want to invest, you have to kind of shop around. Or when you're about to buy a house or a car, you got to go shop around to see which institution is giving you the best for your money. I mean, you're going to borrow, especially if you're buying a house, you're going to borrow at least, what, $300,000? Some of us are buying $4, $5, $6, $1 million home. And I mean, it's going to be a big difference between a 4% and a 4.1 and a 3.95. So you have to be smart enough to compare. Okay. So we're going to, this one's a compounded daily. So I'm going to use your formula that we have not used on example 1, which is, let's flip back here. Okay. We're going to use this one, compound interest formula. A equals P times a quantity of 1 plus R over N to the power of NT. Okay, because it says daily. So let's write the formula down. So A equals P times 1 plus R over N to the power NT. All right. Compounded monthly, we're going to use the same formula. A equals P times 1 plus R over N to the power of NT. And we're going to do continuously, which is part P times E to the RT. All right. So here we go. Let's see how much money we are going to have at the end. Okay. And there are multiple ways of doing this one. Okay. So the one thing that I'm going to do for you is to do the easiest way that I can think of. There's also a method called the effective rate of interest, which I'm not going to teach you. So in order to do this correctly, let's pick an initial amount. Okay, I want to pick the same initial amount for the 3 banks. Let's say you're rich and you have $10,000. Okay, A equals $10,000 times 1 plus your rate for this one is 0.04. Compounded daily, that's 365 days in a year, times N, which is 365, power of T, which we're going to do, looks like, how many years are we? I didn't write down how many years. Let's do 1 year, okay? Or let's just do that. Let's say that at $10,000, most of you are what? Juniors? So let's do 2 years, okay? 2 years. Okay, we just have to be consistent for all of them. Okay, so we are going to put in a calculator. We're going to do 0.01. Again, I don't want you to round to the very end. Okay, so 0.04 divided by 365, enter, which is a really tiny number. A lot of you don't know what this means. This means you have, this is a scientific number, 1.095890411 times 10 to the negative 4. That means I'm moving 4 decimal places to the left. That means it's very close to 0. But it's okay, I'm going to add 1 to it. So add 1. So now I have 1 point. So you notice how there's 3 more zeros in front. And to the power of, so caret, 365 times 2 years. So 365 times 2. All right. So I got a slightly bigger number than that, times 10,000. All right, so after 2 years, with my $10,000 compounded daily, I'm going to take home $10,832.82. Okay? And because we're dealing with money, always round to 2 decimal places at the very, very last step. All right, how about Bank B? They're interested in offering you 4.1%. Let's see how much I'm going to take home after 2 years. A equals, and again, you're going to start with the same amount. And that's the only way that you would be able to compare if you have a constant amount to start to invest. Your rate is 4.1%, so that's 0.041. Divided by n is monthly, so 12 months a year, times NT, so again, till times a year, we decide 2 years. Okay, so let's do that one more time, clear that out. 0.01 divided by 12 to the power of, the answer to the power of 12 times 2, which is actually 24. Okay, so I'll just write 24. So now that's what I have. Oh, you know what? I didn't add 1. Oops. Okay, do that again. So 0.041 divided by 12 plus 1, okay, to the power of 12 times 2, which is 24. Now I have that, and then I'm going to multiply that to my $10,000. Okay, so I have A equals 10,853.04. So $10,853.04. Okay. So far, the 4.1% is kind of beating, it's offering, it's a better rate than this one. It's about, what, 20 bucks? Okay. Then how about continuous? A equals 10,000 times e to the rate of 0.0395 times 2 years. Okay, the 2 years is still the fixed rate there. So let's talk about this. So E second ln, there's my E, 0.0395 times 2. Close that up. Okay, so that's what E to the decimal is. Remember, you can't round into the end, so times 10,000. So A equals 10,822.04. Okay. So let's check out all of our investments. So right now, looks like the best rate for us is, let's say this is 10,832, 10,853, 10,822. Looks like the best rate is Bank B. Okay. So Bank B is what we're going to go with. Okay. All right. Let me move up a little bit. Okay, we're going to do, let's see how much we can accomplish in the next few minutes. Okay. All right, example 3. A zero coupon, which is a non-interest bearing, bond can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want a return of a 7% compounded monthly or 6% compounded continuously? Now, there's a reason why this problem is given to you. A lot of times grandparents or parents like to give their kids or their grandkids money when they turn 18 or when they go to college. So for example, my triplets, they're 4 right now. So when they go to college in 14 years, I would like to give them, let's just say, an amount of $50,000. Okay. Keep in mind that tuition is already at $45,000 at a private school. So $50,000 will probably in 14 years pay for less than 1 year of tuition. So let's just say that I want to give him $50,000 in 14 years. Okay. Then this right here is calculating how much I need to put in now, right? How much do I need to put into each of my triplets' bank account in order for them to earn $50,000 in 14 years? So that's why we're going backwards. All right, one says is compounded monthly and one is compound continuously. So these will be 2 different formulas. So continuously, that's a measure work. A equals P times E to the RT. And monthly is we're going to use A equals P times 1 plus R over n times to the power nt. Okay. Now technically, can you use a different formula? Sure, but why try to remember a lot of things where we can just work backwards, okay? So zero coupon non-interest bearing bond can be redeemed in 10 years. So we know the T is 10 for $1,000. So that's your ending amount, okay? So your $1,000 is your ending amount. P is something that we need to know now. How much do we have to deposit now? So 1 plus your rate is 0.07 divided by monthly, which is 12 times a year, to the power of n is 12, t is 10, because it says right there. Okay, so we're just going to go work backwards to find what p is. So first, I'm just going to 12 times 10 is 120. Okay, so this is 1,000 equals p times. I'm going to divide 0.07 by 12. So 0.07 divided by 12. Add 1. And again, I don't want you to round until the very, very end, okay? So I'm just going to write all of those decimals out. Here we go. 1.005, and 3 to the 120 power, okay? All right, so now I'm just going to take that and raise it to 120 power. That gives me 2.9661377. And then because I'm solving for p, so what I'm going to do is I'm going to divide both sides by that amount. Okay, that means I'm going to do now 1,000 divided by this answer. So 1,000 divided by second answer. Oops. Okay, which is the 2 point, which is going to give me, well, that's not what I want. Okay, never mind. Do this again. 1,000 divided by, I'm just going to put all of the decimals in. Here we go. 1.0058, 1, 2, 3, 4, 5 threes. This is to a power of 120. I think that's what I needed to do. Okay, so $497.60 is what P comes out to be. So P comes out, put the unit in, $497.60. Okay. So if I were to invest now for 10 years at 7% compounded monthly, I would have to put in about $500. Okay, so to earn $1,000 in 10 years. All right, what if I do PERT? Do I put more or less? So let's see. So A is what we are going to end up with, which is $1,000 equals. P is the amount of money that we need to invest now. E is E. Rate is 0.06. T is 10 years. Okay, so here we go. We're just going to divide both sides by e to the 0.06 times 10. 0.06 times 10 is just really 0.6, okay? So here we go. 1,000 equals p times e to the 0.6. Divide both sides by e to the 0.6. Again, I don't want you to round, okay, until the end. So p comes out to be, so what is 1,000? 1,000 divided by, open parentheses, second e to the 0.6, close it twice, $548. $548 unit of measurement and 81 cents. Okay, so looks like the 6% is not a good idea. Okay, obviously I want to put in less to get out. If I were to get out the same amount of money in 10 years, I rather put in less now. So it looks like the 7% is a better investment for us. All right, and that concludes our day. I will see you. Actually, you know what? Let's just finish up example 4. This is our last example. I just forgot that this is the only thing that's left. All right. Example 4. What annual rate of interest? What annual rate of interest compounded quarterly should you seek if you want to double your investment in 6 years? Okay, so let's see what we have. We know time is 6 years. Okay, we are looking for the interest rate, and we know compounded quarterly. So compounded quarterly. Okay, so that means I'm not going to use PERT, but I am going to use A equals P times 1 plus R over N to the power of NT. Alright, so here we go. If I want to double, so let's just say I'm going to start out with $1. If I want to double, I'm going to end up with 2. Would you agree with that? Okay. Initial amount, and if I want to earn twice as much or double, I'm going to end up with 2. You can use 1,000 and 2,000. You can do 2,000 and 4, but why? Right? I can just start with $1. So I'm going to do 1 plus. Looks like my interest rate is what I'm looking for. What annual rate? So now that's going to say it's R. N is how many times a year? Is this compounded quarterly? So that's 4 times a year. To 4 to the power of 4 times 6 is my T. 4 times 6. So I'm sorry, these are exponents, so I shouldn't have that big of parentheses. So right now I have 2 equals 1 times anything, it's really itself, 1 plus R over 4, 4 times 6 to the power of 24. Okay. To get rid of power of 24, you can do 2 ways. You can take the 24th root, or you can use log. So I'm just going to take the 24th root. Alright, so all the way over here, I'm out of space. So $2, 24th root. And if I were to take 24th root of power 24, that cancel each other out. So now I'm with 1 plus R over 4. So now 24th root of 2 is the same as 2 to the power of 1 divided by 24. Just like square root is, just like square root is the same as 1 as to the power of 1/2. So 24th root of 2 is 1.02. Let me write that out. 1.029302237. Okay, again, I don't want you to round it to the very end. Equals 1 plus R over 4. Subtract 1 from both sides. Okay, so minus 1 equals, alright, here we go. And then I'm going to multiply both sides by 4. So times 4 equals, looks like after I do that, rate is 0.117208946. So rate is in percentage. So if I were to move 2 decimal places, it would be 11.72%. So if I want to double my investment, I would have to seek a rate of almost 12%, which is honestly not possible at this time. Alright, that's it for sure this time. This is the end. Have a good day. Bye-bye.